reflection of light. Okay, yesterday we studied about reflection of light. Today I'll be showing a video corresponding to this diagram. Okay, how we can perform these experiments of reflection of light at home. Even you people can perform, right? According to the same diagram where I left. Okay, this is the normal, this is incident ray, reflected ray, right? And this is point of incidence. Normal, incident ray, reflected ray, angle of incidence, angle of reflection. Okay, and we also studied according to the laws of reflection, angle of incidence must be equal to angle of reflection, right? Okay, so I'm going to share a video with you where you can clearly see incident rays and reflected rays in the form of pencils. Okay, pens. You can also perform at home. Incident ray, reflected ray, normal. This angle will be angle of incidence. This will be angle of reflection. And when we will measure, these two angles will come out to be the same. They will come out to be the equal. And you can see their images also. Okay, how clearly their images you can see on the screen, right? All right, same thing we can do with the help of a laser light also. Okay, you all can manage a toy laser light at home and see using that also how we can study reflection of light. For this, this is the apparatus that I have prepared. Okay, this is the apparatus in which there is a mirror strip, a glass slab, and a prism. Okay, so when I'll throw light, laser light on this mirror strip, okay, when I'll throw laser light on this mirror strip, see how reflected light is seen. Okay, and also not only reflected light, if I go on changing the angle of incidence, angle of reflection also automatically changes. Okay, so I'll show you. Still students are entering. So I'll share a video with you in which this is shown very clearly. Okay. This is in darkness, dark view, in light. Then I'll show you the darkness view also. You see incident ray and reflected ray both are so clear. And when I narrowed, when I changed, reduced the angle of incidence, angle of reflection also changed. I show you once again. Incident ray with the help of laser light I have thrown on the mirror, plane mirror strip. Okay, and see, this is reflected ray, so clearly it is visible. Okay, one more thing I want to show. In dark, when we see, what kind of view we see? Note that also. See, angle of incidence is small, reflection, angle of reflection is also small. When I increase angle of incidence, angle of reflection also increases so much. Okay, so this is in dark, the view. I hope this is clear to you now. Okay. All right. So how interesting the experiments of light can be. You can also try at home, right? So this is about the reflection of light. Now let's take a special case. What will happen if the ray of light were incident normally? Okay, what will happen if the ray of light were incident normally on the mirror? Normally means perpendicular. Let us draw it. So again, this is the mirror and rays falling normally on it. It will come back. According to the rules, it will come back. Why? Because angle of incidence was 0 degree. Okay, it is not 90 degree as you can think. It is not 90 degree because according to definition, angle of incidence is the angle between normal and incident ray. So this is also normal. Normal will also be along this and incident ray is also along this. So angle between incident ray and normal angle of incidence is 0 degree in this case. According to the laws of reflection, R is always equal to angle of incidence. So angle of reflection is also 0 degree. So that means reflected ray should also be along it. How it is possible? If the ray strikes and comes back. So it retraces its path for normal incidence. Is that clear? So for normal incidence, the ray will retrace its path. Okay. So note down this question. Note this question down. What happens for normal incidence? Okay. What happens to normal incidence? So you will write when a ray of light is incident on a plane mirror normally, it retraces its path. It comes back along the same path because angle of reflection is 0 degree. Angle of reflection is 0 degree. All right, students. I hope this logic is clear to you. So now we are going to draw image formed by a plane mirror. Yesterday we did virtual images. I told you the image formed by plane mirror will be virtual. How? Let us draw the ray diagram, right? So image formation by a plane mirror. Image formation by a plane mirror. Image formation by a plane mirror. So let us take a plane mirror now. Let us keep it like this. A mirror mm dash. This is a plane mirror mm dash. All right. I have kept an object in front of you. Suppose I have kept an object AB. Maybe a candle or any object. Okay. It is not necessary that it should be shining. It should be having light. It is not necessary because when any object is kept in front of a mirror, its image is always seen. Okay, because different rays of light, they travel from this object towards the mirror and strike it. Let us take one ray of light that is arising, that is coming out from the tip of the object. Obviously, it is perpendicular. It is hitting the mirror perpendicular normally. So according to the rules, it will come back. It will retrace its path. So one ray we have taken coming out of tip of the object. Let us take one more ray which is coming out of foot of the object. It is also hitting the mirror normally. So reflected ray will again be along the same line. Reflected ray will again retrace its path. Up till here it is clear. Let's take one more ray which is emerging out at certain angle and hitting like this. It is hitting the mirror at certain angle theta. Let us say it hits the mirror at certain angle theta. Then according to the laws of reflection, covering the same angle theta, reflected ray will come back. Okay, this is the same portion that we had drawn like this. Now we are drawing it like this, right? So one more reflected ray we have got. So we are having three reflected rays. If we see their path, they are coming like this. They will never meet here. These two parallel lines are never going to meet, we know. And these rays will also never meet because angle between them is increasing and increasing. They will never meet in this direction. Means these rays of light will never meet actually. So how will the image be formed? If we imagine the reflected rays to be produced backwards. So let us produce the reflected rays backwards. Let us produce the reflected rays backwards. All right. Produce all the rays backwards. Where they will cut? These two rays are cutting here. That means image will be formed here. And since they are not actually meeting, they appear to meet. That's why this image is not real. It is virtual image. So this is what I mean by real and virtual images. The rays are not actually meeting here. We have imagined, we have produced them backwards, then they are able to meet. All right. So is the concept clear? How is a virtual image formed? When the rays don't actually meet at a point, they appear to meet at a point. So the rays of light, they appear to meet here, and we always draw the arrow where the rays cut. So that means image formed is erect. Okay, they are cutting here. That means arrow is to be put here. So that means the image formed is erect. That is why when we see our face in a plane mirror, it appears to be erect. It is not inverted, it is erect. Okay, so this is the ray diagram showing image formation by a plane mirror. Okay, now let's write the characteristics. Characteristics of the image formed. Characteristics of the image formed. First characteristic, image is virtual. We have proved that the image formed is virtual, right? Because rays were not actually meeting, they appear to meet at certain point. So first characteristic of image formed is it is virtual. Second characteristic is it is erect. Also we know that virtual image is always erect. So image formed is erect, सीधी है, सीधी बन रही है, right? Third characteristic is we can see from the diagram size of object and size of image. Let us call the image A dash B dash. Size of object and image are the same. आपको अपना फेस सेम साइज का दिखाई देता है ना प्लेन मिरर में. So that means third characteristic is size of image is equal to size of object. Size of object. Fourth characteristic, size of image is equal to size of object. Now fourth characteristic is distance between object and mirror. This distance u is always equal to distance between image and mirror v. Object distance is equal to image distance. And you also notice this point when you are standing in front of a plane mirror. जितना डिस्टेंस आपका मिरर से होता है उतना ही डिस्टेंस पे आपको अपनी इमेज मिरर से दिखती है. सो डिस्टेंस बिटवीन ऑब्जेक्ट एंड मिरर is always same as distance between its image and mirror. Okay, and we can also prove it mathematically from this ray diagram. Okay, I'll show you, but first write the characteristic. I write the fourth characteristic here. Object distance is equal to image distance. Object distance is equal to image distance always. What do we mean by object distance? Distance between object and mirror is called object distance and usually we denote it by u. And what do we mean by image distance? It is the distance between image and mirror and that is usually denoted by v. Okay, so fourth characteristic of image formed by a plane mirror is that object distance will always be equal to the image distance. All right, let us prove it now. If this is angle theta, this will be alternate angle theta. If this is angle theta, this is also corresponding angle theta. and these two angles will be equal because we know that angle of incidence and angle of reflection will be same. Okay, so this is I, this is R. हमने उसको theta ले लिया because they are same. So these two angles are the same. Let us take angle 1 and angle 2 here. These are both equal to 90 degree. Both these angles 1 and 2 are each 90 degree. So let us take two triangles, two right angle triangles, AMM dash, this one, and A dash MM dash, this one. Let us take these two shaded triangles. In these two triangles, you will write angle 1 is equal to angle 2, each equal to 90 degree. Okay, this angle theta is equal to this angle because angle I is equal to angle R. आप उनको कोई भी name दे सकते हो, angle 3, angle 4 you can write, or even I and R you can write. Okay, so in these two triangles, angle 1 is equal to angle 2, each equal to 90 degree. This angle is equal to this angle. अगर IR लिखना है तो IR लिख लो. Okay, because of reflection, and MM dash is equal to MM dash, common. MM dash is equal to MM dash, that is common. So these two triangles are congruent. That means these two triangles are congruent. So this side AM is equal to A dash M. So U is equal to V. This is how we can prove that object distance is equal to image distance. Fine, is that clear, students? Right? So if you want, I can write this here. Let me write this explanation. In triangle AMM dash and triangle A dash MM dash, what will happen? MM dash is equal to MM dash, common. Angle 1 is equal to angle 2, each equal to 90 degree. Okay, let us call it angle I and angle R. So this is I and this is R. Angle I is equal to angle R, that is laws of reflection. From the laws of reflection we know that. Therefore, these two triangles are congruent. These two triangles are congruent. Therefore, we can write AM is equal to A dash M. U is equal to V. Object distance is equal to image distance. So this is proved. All right, very small treatment. We are just proving that these two triangles are congruent. So that means these two sides are equal. So this is fourth property of plane mirror. Is that clear? Okay. Now next property, last property of plane mirror is that image formed is laterally inverted. Okay, we use this word. Fifth characteristic is the image formed is laterally inverted. What does that mean? What is lateral inversion? What is lateral inversion? Let us study about that. When an object is kept in front of a plane mirror, this is a plane mirror, and a 7-shaped object is suppose kept in front of it, how will it look like in the mirror? It will look like this. Its left hand side will appear to be the right hand side, and right hand side will appear to be the left hand side when it is kept in front of a plane mirror. This phenomenon is called lateral inversion. Okay, so image is always laterally inverted in front of a plane mirror. In front of a plane mirror, it will always be laterally inverted. Okay, so write down the definition of lateral inversion. When an object is kept in front of a plane mirror, its left hand side appears to be the right hand side and vice versa. When an object is kept in front of a plane mirror, its left hand side appears to be the right hand side and vice versa, means reverse is also true. Sometimes the students, they forget to write plane mirror. When the object is kept in front of a plane mirror, they just write what is lateral inversion. in which the object left hand side appears to be right hand side and vice versa. But when it doesn't happen always, it happens only when the object is kept in front of a plane mirror. So you need to mention it. Okay, very common question you will find in books, that if ambulance word is written, okay, and it is kept in front of plane mirror, how it will look like. Okay, it is analogous to this. This is the mirror image. Okay, on one side we can read the actual word, on the other side you will be able to see its mirror image. This is laterally inverted image of the object. Very common question given in books. So these are all very interesting experiments and small activities related to light and reflection of light. You people can try yourself also at home. So I hope this concept of image formation by plane mirror is clear to you. Okay, plane mirror is clear now. Let us now move on towards the spherical mirrors. Next topic is spherical mirrors. Before we proceed further, I'll give you one question to do. Yesterday also I gave you one question to do. That was, so I'm going to tell you the answer. If a plane mirror is turned through an angle theta, what is the angle through which reflected ray would turn? The answer will be 2 theta. If plane mirror is turned through an angle theta, reflected ray will turn through an angle 2 theta. Okay, so you people can try whether you have solved correctly or not. And now note down one more question that you will do based on this concept of plane mirrors only. Write down. What is the minimum length? What is the minimum length of a plane mirror required to see? What is the minimum length of a plane mirror required to see the full image of a man of height h? Required to see the full image of a man of height h. If the height of man is h, what should be minimum length of plane mirror so that we can see his full image in it? So what is the minimum length of a plane mirror required to see the full image of a man of height h? So I'll wait for your answer, and you can draw the relevant ray diagram also, that how your answer should be that. Okay, so we will be discussing next week, right? So next topic we come to, that is spherical mirror. Spherical mirrors. So I told you there are 2 types of spherical mirrors that we are going to discuss: concave mirror and convex mirror. Concave mirror and convex mirror. Okay, so these 2 types of mirrors we will be discussing. Now let us have a sphere. Okay, we have a sphere which has been painted red or made opaque from outside. It has been painted red from outside and it has been polished silver from inside. Okay, if we cut any part of this sphere, we will get a concave mirror. So this part of this sphere which has been polished silver from inside and painted red from outside, this is called a concave mirror. So write down the definition of concave mirror. I showed you concave mirror yesterday, that inner bulging portion of a spoon, that is concave. So write down the definition of concave mirror. Concave mirror is the mirror which is a part of a sphere. It is a mirror which is the part of a sphere which is polished silver from inside, means which is reflecting from inside, which is polished silver from inside and painted red from outside or made opaque from the outer side. So ऐसे स्फीयर के पार्ट को हम क्या कहेंगे? concave mirror. Okay, so I am drawing only a part of this sphere. This is definitely a concave mirror. So this is a concave mirror. Okay, this is a concave mirror. So always remember, we will keep its inner bulging portion shining and outermost portion that will be opaque. It will be insensitive to light. Light will be reflected from the inner portion, inward portion of the mirror. All right. Now on the other hand, convex mirror, it is the part of a sphere which has been painted red from inside, which has been made opaque from inside, and its outer surface is shining. Its outer surface is polished silver to make it reflecting. Outer surface is polished to make it reflecting. Okay. So when I cut a part from such a sphere, I get a convex mirror. I will get a convex mirror. So I am rubbing the rest of portion and see how I will get a convex mirror. So a part of such a sphere, this is a convex mirror. So write down the definition of convex mirror. It's the part of a sphere. It is the part of a sphere which is polished silver from outside, and painted red from inside to make it opaque. So always remember, this is concave mirror and this is convex mirror. अगर आपको मिरर ही ड्रॉ नहीं करना आता तो सारा क्वेश्चन रॉन्ग हो जाएगा. Whether it is numerical or you want to draw an image formation, if mirror drawn is wrong, then the whole concept will go wrong. So this is the first thing which is very, very basic. Now we will be doing terminology related to the mirrors. Okay, terminology related to the mirrors. So go on writing. First term is aperture. What is aperture? Like this AA dash is aperture of the mirror. This AA dash is aperture of the mirror. It is the part of mirror from which reflection can take place. It is that part of mirror which is reflecting or from which reflection can take place. So from whole of this part, reflection can take place. So that's why this is also the aperture of the mirror. So write down the definition of aperture in both the cases, right? This is aperture of convex mirror, AA dash. So write down aperture, the part of mirror from which reflection can take place. The part of mirror from which reflection can take place, that is called aperture. That is called aperture. Right. Next term is pole. What is pole of a mirror? Pole of a mirror. Center of aperture or center of mirror is called pole. In both the cases, this is pole. Center of the mirror is called pole P. Okay. Pole is clear to you? Center of the mirror is called pole. So on both sides I am marking the points side by side. Third thing is principal axis. What is principal axis? A line passing through pole of the mirror, that is called principal axis. This is principal axis of concave mirror and this is principal axis of convex mirror. So a line passing through pole of mirror, that is called principal axis. Principal axis. Next is radius of curvature. Radius of curvature, capital R is the symbol. Radius of curvature. If I again imagine that sphere from which I had cut this mirror, if I imagine that sphere, then center of that sphere is called center of curvature, and radius of that sphere will be called radius of curvature. So there are two terms. Okay, radius of curvature and center of curvature. First, write the definition of radius of curvature. It is the radius of the sphere of which the mirror is a part. You understand this? I have completed that sphere and I have marked the center of that sphere. That is called center of curvature. And the radius of that sphere will be called radius of curvature. Right? So how do we define radius of curvature? It is the radius of sphere of which the mirror is a part. Here also, I complete the sphere and I mark its center point C. This is center of curvature and this is radius of curvature R. So it is always the radius of sphere of which the mirror is a part. Next term is center of curvature. Center of curvature C. Center of curvature C. It is the center of sphere of which the mirror is a part. It is the center of sphere of which the mirror is a part. Center of sphere of which the mirror is a part, that is called center of curvature C. All right, students, is this clear to you? All right.